Hi, I'm Simon Jory Stevens-Giel. This is Generating Discourse Connectives with Pre-trained Language Models, Discourse Relations Help yet again. Presented on behalf of myself, Sandra Mastrovilli, Sintong Lee, and Michael White. Contemporary neural approaches to NLG frequently issue explicit representations of discourse structure in their input. This contrasts with earlier pipeline models, which often featured richer input representations. The work reported on here concerns whether state-of-the-art pre-trained neural networks can consistently produce discourse connectives without including discourse relations in the input. And we pursued this question by experimenting with BART. So we trained two types of model. D+ stands for the model type fine-tuned on input including an intended discourse relation. D- stands for the model type fine-tuned on the same input except for the absence of a discourse relation. We report on other variants of these models in our paper. And the rest of the slides will just be considering the variant where D- performed best. Now, besides the discourse relation, inputs were composed of text spans from the Penn Discourse Tree Bank, while the outputs corresponded to full sentences made of the input text and possibly a discourse connective. Now, with respect to recovering the connective used in the reference text, our D+ model significantly improved over the D- model, which you can see here. You might, however, wonder whether this is an obvious result. Well, whether the result seems obvious, it hasn't been shown empirically until now that conditioning on discourse relations improves the performance of neural models in reliably producing the intended discourse relation that holds between text spans in a broad coverage setting. We compared our match rates to 4 baselines. So the majority D+ is where the choice of connective is the most frequent connective which could realize the discourse relation. Majority D- is when the choice of connective is just the most frequent connective overall, and BART large and BERT are used off the shelf. So we also compared our models with reference to psycholinguistic hypotheses, which have been shown consistent with discourse connective usage in the PDTB. We consider the following hypotheses. Continuity hypothesis holds that readers have a bias towards interpreting sentences in a narrative as following one another in a continuous manner. The causality by default hypothesis holds that because readers aim at building the most informative representation, they started assuming the relation between two consecutive sentences is a causal relation. So, given these hypotheses and a typology of PDTB in terms of continuity and causality, we predict that continuous and causal relations are likely to be less marked and more frequently implicit. So here, implicitness is implicitness of a discourse relation, and that corresponds to the proportion of implicit versus explicit expressions of the relation. Markedness of a discourse relation is how close the co-occurrence of the relation and its corresponding connectives is to being unique. So in other words, continuous and causal relations are expected to be realized more frequently by a wider range of connectives. We find the distributions of markedness and implicitness for our D+ results are close to the distributions for the reference text. D- is considerably worse in this respect. To be more specific, we find the mismatches in D- are what we'd expect if the model were overgeneralizing the patterns of connective use predicted by the psycholinguistic hypotheses. And this can be seen on the next slide, where D- generates a causal connective, even when the intended discourse relation isn't causal. So here we see an example of the reference text, the input, and the output. We see that the D+ output correctly recovers the connective and in the reference text. The D- model misses this and erroneously produces because. The difference in inputs between the two models is a discourse relation highlighted in yellow, which is absent in D-. The connective, discourse relation, and arguments are reconstructed with the PDTB annotation. The left and right contexts are the minimal text preceding and following the arguments necessary to ensure the output is comprised of full sentences. And these contexts are automatically recovered from the Wall Street Journal text for which the PDTB provides annotation. Here we show the markedness measure of 4 discourse relations, which exemplify the distinction between causal or continuous relations and non-causal or discontinuous relations. While the comparison and temporal asynchronous are thought to be the most marked, D- doesn't reflect this. Moreover, D minus doesn't reflect the markedness difference between these relations, nor the extent to which their markedness scores dwarf the causal and continuous relations, contingency cause and expansion instantiation. This graph shows that conditioning on discourse relations produces a closer match between the reference connectives and generated connectives. Here, the exact matches are on the bottom and the mismatches on the top. So mismatches in D plus are more likely to express the intended relation than those in the D minus models. And notice that the mismatch category other, which is at the top, is much bigger for the D minus model. This corresponds to mismatches where the chosen connective is neither the reference connective nor implicit, nor even one of the other connectives which can realize the intended discourse relation. The graph here shows that with the exception of comparison, the implicitness of discourse relations for D plus is quite close to the reference. The D minus errors are often more severe. In other words, they produce explicit connectives which express the wrong relation more frequently than the D plus model. So our results show that conditioning on discourse relations significantly improves the likelihood of the model's output matching the reference connective. And when we consider connective usage patterns which are argued to reflect cognitive heuristics, we find that conditioning on discourse relations improves the fit between the reference usage patterns and usage patterns extracted from the model output. Our results suggest future work should consider incorporating discourse relations into input representations. We'd like to thank our reviewers and also a research agreement between Facebook and The Ohio State University that supported this work. Finally, most importantly, we want to thank you for listening. P.S. BART agrees that discourse relations help NLG.